Let us learn permutations. The definition of permutation is: a permutation is an arrangement in a definite order of a number of objects taken some or all at a time. So basically, permutation means arrangement of the selected objects. Let us consider that we have n different objects and we have to select R at a time and arrange those selected R objects. The condition for R is 0 less than or equal to R less than or equal to n, and no repetition. We have n different objects, out of which we are going to select R objects and permute them. So NPR is the formula. The formula is n factorial divided by n minus R factorial. We have to fill up R places. So the first place can be filled up in n ways. This in n minus 1 ways. Here n minus 2. So for the rth place we have n minus of R minus 1 choices. Therefore, the number of ways is equal to n into n minus 1 into n minus 2 into etc. up to n minus R plus 1. From this we get this formula. If n minus R factorial is cancelled from n factorial, we get this product. For example, if we have 3 digits, 1, 2, 3 say, we have to select any 2 digits and arrange them. For example, I can select 1 and 2 or 2 and 3, or I may select 1 and 3. This is only selection. So we have 3 combinations. Each combination has 2 ways of arrangement. It can be 12 or 21, or here we can form 23 or 32. Here we can arrange them and form 13 or 31. We have 6 permutations. Number of permutations will be always more than number of combinations. 3 digits are given. In case we have to make use of all 3 digits. So number of permutations will be 3p3, which is 3 factorial by 0 factorial. 0 factorial is 1. Therefore, the answer is 3 factorial. If we have n different objects and we have to arrange all n objects, no repetition here. The formula is npn, where R is equal to n here. It becomes n factorial by 0 factorial, which is n factorial. This is the first formula. We are going to learn 3 permutation formulae. The second formula, here also we have n different objects. But repetition is allowed. For example, we have to fill up R positions, say. For the first position, we have n choices. For the second, n choices because repetition is allowed. For the third position, n choices, etc. For the rth position also, we have n choices. Therefore, total number of ways will be n into n R times. So the answer becomes n raised to R. If n different objects are given, to fill up R positions when repetition is allowed, the formula is n raised to R. For example, here we have the digits 1, 2, 3 given, and we have to form a 2-digit number where repetition is allowed, say. Then, ones place digit can be filled up in 3 ways. Since repetition is allowed, this also has 3 ways. Therefore, total number of arrangements will be 3 3s are 9. That is 3 squared. The third formula, permutation when the objects are identical. Out of n given objects, P1 objects are of same kind, P2 objects are of same kind, etc. Pk objects are of same kind, say. Then number of permutations will be n factorial divided by P1 factorial into P2 factorial, etc. into Pk factorial. These formulae are given in your textbook as Theorem 1, Theorem 2 and Theorem 4. Now for the third formula, let us consider this example. Let the digits given be 1, 1, 2. We have two identical items here. And we have to form a 3-digit number, say. Let us consider the permutation of all these 3 digits. It can be 1, 1, 2, 1, 2, 1 or 2, 1, 1. If I permute, if I interchange these two ones, I get the same number. Similarly, here also I get the same number. So, number of permutations are reduced when you have identical items. Therefore, the number of ways will be 3 factorial divided by, out of these 3 items, we have 2 identical items. Therefore, the answer is 3. Now, let us sum up all the 3 formulae which we learnt. The first one is, if you have n different objects, out of which you have to select R and permute them, the formula is n factorial by n minus R factorial. Here no repetition. And distinct objects, n distinct objects you have. This is the first formula. And npn, you can use the same formula, that is n objects are given, you have to arrange all n objects. So the formula becomes n factorial by 0 factorial. We know the value of 0 factorial, which is 1. Therefore, npn is n factorial. Then the second formula, you have n objects and you have to select R objects and arrange those R objects, but repetition is allowed here. If repetition is allowed, I told you we cannot use this NPR formula. So it becomes n power R. So number of ways is equal to n into R times. So it becomes n power R. This is the second formula where repetition is allowed. The third one is, if you have identical items, then the number of ways will get reduced. So you have n objects, out of which P1 objects are of same kind, P2 objects are of same kind, etc. Pk objects are of same kind. So you have to divide by P1 factorial multiplied by P2 factorial, etc. multiplied by Pk factorial. So these are the 3 types of different permutation questions which we may get. This is an interesting lesson. You have to understand and do this lesson. You cannot just memorize the formula and apply, because each question is going to be different. Memorize these 3 formulae. Let us start exercise 7.3. First question. How many 3-digit numbers can be formed by using the digits 1 to 9 if no digit is repeated? Let us write down the conditions given. First one, it should be a 3-digit number. And the second condition, we have to make use of the digits 1 to 9. 1 to 9 we have 9 digits. And then the third condition, no repetition. So total number of ways is equal to, here 9 different digits are given, out of which we have to select 3 digits and arrange. So it is a permutation question. So 9p3 is the formula. We are using NPR formula, which is 9 factorial divided by 9 minus 3, 6 factorial. Cancel 6 factorial, 7, 8 and 9. The answer is 72 times 7, 504. We can use fundamental principle of counting also. We have to form a 3-digit number. So ones place digit can be filled up in 9 ways. And for tens place we have 8 choices. Repetition is not allowed here. For this 7. So the answer is 7 times 8 times 9, which is 504. Question 2. How many 4-digit numbers are there with no digit repeated? So the first condition is it should be a 4-digit number. And second condition is no digit repeated. We can make use of all the 10 digits 0 to 9. Here we cannot use 0. If we use 0 in thousands place, for example 0, 2, 4, 7 say, it becomes a 3-digit number. But we have to form a 4-digit number. So we have a condition for this thousands place. We cannot use 0. If we have condition for a certain position, fill up that position first. So the number of ways to fill up this position is 9, because 0 cannot be used. For the rest of the 3 positions, we can use permutation. Now the leftover we have 9 digits, out of which we have to select 3 and arrange. So 9p3. Therefore, number of ways is equal to 9 times 9p3. You can write the steps separately. For thousands place digit, the number of ways is equal to 9. For the other 3 digits, the number of ways is equal to 9p3. 9p3 is 9 factorial divided by 9 minus 3, which is 6 factorial. Cancel 6 factorial, 7, 8 and 9. The answer is 4536. We can use fundamental principle of counting also for this question. For this position we have 9 choices, and then we have 1 digit has been used for this position. Then we have 9 choices here, then 8 and then 7. So we get the same answer. Question number 3. How many 3-digit even numbers can be made using the digits 1, 2, 3, 4, 6, 7 if no digit is repeated? So the first condition is it should be a 3-digit number. The second condition is it is an even number. The third condition, using the digits 1, 2, 3, 4, 6 and 7. And the fourth condition is no digit is repeated. We decide whether the number is even or odd by looking at the units place digit. So let us fill up that position first. It should be an even number. The even number should end with 2 or 4 or 6. We have 3 choices. Then for these 2 positions we can use permutation. So out of the 6 digits given, we have used 1 digit for this units place. Now we have 5 remaining digits, out of which we have to select 2 and arrange, which can be done in 5p2 ways. So for units place, we have 3 choices. For the other 2 places, 5p2 ways. Therefore, number of ways is equal to 3 times 5p2, which is 3 into 5 factorial by 3 factorial. 4 times 5, which is 60. Or we may use fundamental principle of counting. This units place has 3 choices and this tens place will have 5 choices, because out of 6 digits given, 1 has been used for the units place and here 4. So 4 into 5 into 3. So you may use any method. Question 4. Find the number of 4-digit numbers that can be formed using the digits 1, 2, 3, 4, 5. If no digit is repeated, how many of these will be even? In this question, we have 2 questions. The first condition is it should be a 4-digit number. And the second condition is using the digits 1, 2, 3, 4, 5. Third condition is no repeats. We have to form a 4-digit number. 5 digits are given. So out of 5 digits, select any 4 digits and arrange. So NPR formula. So number of ways is equal to 5p4, which is 5 factorial divided by 5 minus 4, 1 factorial. The answer is 5 factorial. 5 factorial is 120. Now the second part of the question is, how many of these will be even? So we have one more condition, it should be an even number. So we decide whether the number is even or odd by looking at the units place digit. So this has a condition, so fill up that first. If condition is there for a certain position, we cannot include that in P formula. So this units place digit can be filled up in 2 ways, because we can use either 2 or 4. So number of ways to fill up units place digit is 2. For the remaining 3 places, we have, out of 5 digits, we have used 1 digit here. So from the leftover 4 digits, we can select 3 digits and arrange. For the remaining positions, number of ways is equal to 4p3, which is 4 factorial by 4 minus 3, 1 factorial. 4 factorial is 24. Therefore, total number of ways is equal to 24 times 2, 48. Similarly, you may use fundamental principle of counting. For this, you have 2 ways, and for this position, you have 4, because out of 5 digits, we have used 1 digit for the units place. Then for this 3, for this 2, which is 48. Then question number 5. From a committee of 8 persons, in how many ways can we choose a chairman and a vice chairman, assuming one person cannot hold more than one position? Totally we have 8 persons. We have to select 2 persons and name them as chairman and vice chairman. So it is a permutation question. Totally we have 8 persons. So total number of ways will be 8p2, which is 8 factorial divided by 6 factorial. Cancel 6 factorial, 7 and 8. 7 8s are 56. So we have 56 ways of selecting a chairman and a vice chairman. Question 6. Find n if n minus 1 p3 is to n p4 is equal to 1:9. Let us use NPR formula. NPR is n factorial divided by n minus r factorial. Therefore, we get n minus 1 factorial divided by n minus 1 minus 3 factorial. This is the numerator. Denominator is n factorial divided by n minus 4 factorial equals 1/9. N minus 4 factorial, n minus 4 factorial could be cancelled. The numerator has n minus 1 factorial. The denominator n factorial can be written as n times n minus 1 factorial. Like we can write 7 factorial as 7 times 6 factorial equal to 1/9, so that we can cancel these two. Therefore, n is equal to 9. Question 7, first subdivision. Find R if 5pr is equal to 2 times 6pr minus 1. Let us use NPR formula, which is n factorial divided by n minus r factorial. Five factorial divided by 5 minus r factorial equal to 2 times 6 factorial by 6 minus of r minus 1, which will become 6 minus r plus 1, which is 7 minus r factorial. 5 factorial divided by 5 minus r factorial equals 2 times 6 factorial can be split and written as 6 times 5 factorial. Similarly, the denominator 7 minus r factorial can be written as 7 minus r times 6 minus r multiplied with 5 minus r factorial. We can cancel 5 minus r factorial and 5 factorial, cross multiply. Let us open the brackets. Minus 6r minus 7r will be minus 13r. We are getting a quadratic equation in R. R square minus 13r plus 30 equal to 0. We can factorize by splitting the middle term. The factors are r minus 3 and r minus 10. Therefore, we get two answers for r. R is equal to 3 or r is equal to 10. But we have 5pr term in the question. So 0 less than or equal to r less than or equal to 5. This is the condition for r. It cannot exceed 5. But here r is equal to 10, which is more than 5. So r cannot be 10. Therefore, the final answer for r is 3. Second subdivision. 5pr is equal to 6pr minus 1. NPR formula is n factorial divided by n minus r factorial. 5pr becomes 5 factorial divided by 5 minus r factorial. Here 6 factorial divided by 6 minus of r minus 1, which will become 7 minus r factorial. 5 factorial by 5 minus r factorial equal to 6 factorial can be written as 6 times 5 factorial, and this can be written as 7 minus r, 6 minus r, and 5 minus r factorial. Cross multiply. 42 minus 13r plus r square is 6. We get a quadratic equation. 42 minus 6 is 36 equal to 0. The factors are r minus 4 and r minus 9 equal to 0. We get two answers for r. R is equal to 4 or r is equal to 9. Here also same condition. We have the term 5pr. Therefore, the condition for r is 0 less than or equal to r less than or equal to 5. It cannot be 9. Therefore, the final answer for r is 4. Question number 8. How many words with or without meaning can be formed using all the letters of the word equation? Here we have 8 letters. All 8 letters are different. Equation using each letter exactly once. We have to make use of all 8 letters. So number of ways is equal to 8 letters are given and make use of all 8 letters and arrange. So 8p8 is the formula, which is 8 factorial divided by 0 factorial. 0 factorial value is 1 and 8 factorial is 40320. Ninth question. How many words with or without meaning can be made from the letters of the word Monday? Here we have 6 alphabets. All 6 are different alphabets. Assuming that no letter is repeated, if the first one is 4 letters are used at a time, we have to make use of 4 letters out of 6 given letters. So number of ways is equal to 6 different alphabets are given, out of which we have to select 4 alphabets and arrange permutation. So 6p4. The formula is 6 factorial by 6 minus 4, 2 factorial. Cancel 2 factorial, 3, 4, 5 and 6. The answer is 360. Or you may use fundamental principle of counting. For each position, see the number of ways and multiply, you get the same answer. Second subdivision is all letters are used at a time. So number of ways is equal to 6 alphabets are given. You have to make use of all 6 different alphabets. So 6p6. Use the formula 6 factorial by 0 factorial. 0 factorial is 1. Therefore, the answer is 6 factorial. 6 factorial is 120 into 6, which is 720. Third subdivision. All letters are used, but first letter is a vowel. All letters are used. So, all 6 we have to use. But we have a condition for the first position. This should be a vowel. Let us see how many vowels are there. In the word Monday, O and A. So to fill up the first position, we have two choices. I have told you if you have a condition for a certain position, it cannot be included in P formula. Now for the rest of the positions we can use P. Out of these 6 alphabets, we have used 1 for the first position. Now we have remaining 5 alphabets and all 5 we have to arrange. So 5P, 5. So number of ways for the first place is equal to 2. That is either O or A. Number of ways for the remaining 5 places is equal to 5P5. We will be left with 5 alphabets. All 5 we have to arrange. Therefore, total number of ways is equal to 2 times 5P. 5 is 5 factorial and 5 factorial is 120. Therefore, the answer is 240. Question 10. In how many of the distinct permutations of the letters in Mississippi do the 4 I's not come together? Not coming together we have to do by total minus together cases. So let us first find the total number of cases. How many alphabets we have? 11 alphabets are there, out of which we have 4 I's, 4 S and 2 P's. We have identical alphabets. So total number of ways is equal to 11 factorial divided by, we have to divide by the identical items, the third formula of permutation which we saw. 4 factorial into 4 factorial into 2 factorial. Let us cancel 4 factorial out of 11 factorial. So 5, 6, 7, 8, 9, 10 and 11 divided by 4 factorial into 2 factorial is 2. 2 3s are 6, 4 2s are 8, 315 into 110. The answer is 34650. Now together cases we will calculate. 4 I's together. So together cases we know how to do. We will count them as one alphabet. This is how we do together cases. We have to put the alphabets which are coming together and count them as one alphabet. I am writing the remaining alphabets. Out of the remaining alphabets, I have 4 S and 2 P's, identical alphabets I have. Here we should not consider them as 4 I's because we counted them as one alphabet. Now let us see how many alphabets we have to arrange. This is 1, 2, 3, 4, 5, 6, 7 and 8. Out of these 8 alphabets, we have 4 S and 2 P's, identical alphabets. Don't consider 4 I's because we have counted them as one alphabet. Therefore, number of ways in which 4 I's are together is equal to 8 factorial divided by 4 factorial times 2 factorial.
4 i's among themselves can be arranged in 4 factorial divided by 4 factorial only one way, so into 1.
28 times 30, which is 840. Now we will calculate where 4 i's are not together. Number of ways where i's are not together is equal to total number of cases minus together cases. The answer is 33810. Question 11. In how many ways can the letters of the word permutations be arranged if the words start with P and end with S? The given word is permutations. We have 12 alphabets, out of which we have 2 T's. 2 identical T's are there. The first subdivision, words start with P and end with S. We have fixed 2 alphabets in the first and the last positions. So remaining 10 alphabets we have to arrange, out of which we have 2 T's, which can be done in 10 factorial by 2 factorial. For identical items you have to divide. And for this P, for the first position we have only one choice. For the last position we have only one choice. Now remaining 10 alphabets we have to arrange. P and S are fixed for the first and the last positions. The remaining ten alphabets we have 2 T's. Therefore, number of ways is equal to, for P and S 1 and 1, and for the remaining 10 alphabets it is 10 factorial divided by 2 identical T's are there, so don't forget to divide by 2 factorial. Cancel 2 factorial, 3, 4, 5, 6, 7, 8, 9 and 10. The answer is 18144400. Second subdivision, vowels are all together. The vowels are E, U, A, I, O. All 5 vowels are there. Put them together and count them as one alphabet. Let us write the remaining alphabets. P, R, M, T, T, N, S. 1, 2, 3, 4, 5, 6, 7, 8 alphabets we have to arrange, out of which we have 2 T's. Taking 5 vowels as one alphabet, number of ways is equal to 8 factorial by, for 2 T's you have to divide by 2 factorial. Now these vowels can be arranged among themselves in 5 factorial ways. Vowels should come together, but we can arrange among themselves. So many arrangements are there. See, I can write it like this also. So many arrangements are there. How many arrangements are there among themselves? 5p5, which is 5 factorial. So 5 vowels can be arranged among themselves in 5 factorial ways. Therefore, total number of ways where vowels are together is equal to 8 factorial by 2 factorial times 5 factorial. Cancel 2 factorial, 3, 4, 5, 6, 7 and 8, and 5 factorial is 120. This answer is 2419200. The third subdivision. There are always 4 letters between P and S. Totally we have 12 alphabets. There are 4 letters between P and S. For example, if I write P here, 1, 2, 3, 4 letters should be in between and S can be written here. Or P here, S here. Or P and S. So that 4 letters will be in between these two. P here, S here. Or P here and S here. So we have 7 cases for arranging P and S. The question doesn't say that P should come first and then 4 letters, then S. It can be S first, followed by 4 letters and P. So we have 7 more ways. Or we can have S here and P here. So number of ways to arrange P and S is equal to 7 plus 7, 14. Why are we adding here? Because we can arrange P 4 letters and then S, or we can put S first, then 4 letters and then P. We use the word or, we have to add. And then out of 12 letters, we have arranged 2 letters P and S. The remaining 10 letters should be arranged. Therefore, remaining 10 letters can be arranged in 10 factorial by 2 factorial. What is this 2 factorial for? For 2 t's. Therefore, number of ways is equal to, that is number of ways where 4 letters are between P and S is equal to 14 times 10 factorial by 2 factorial, because we have to arrange P and S as well as the remaining 10 alphabets. So it is multiplication. 14 times 10 factorial divided by 2 factorial. We did it in the first subdivision, which is 18144400, and this multiplication is 25401600.